Okay, in the previous video we looked at how we added and then displayed a raster data set, specifically the digital elevation model, which is on the screen at the moment. We saw that this was a 50 meter digital elevation model, meaning that it had a cell resolution of 50 meters by 50 meters. What I'm going to show you now are two secondary derivatives. Now these are called secondary derivatives because they are derived from the primary model, which is our digital elevation model. And these secondary derivatives are slope, which gives every cell in the dataset a value between 0 and 90 degrees, which represents the gradient of each cell. And the second dataset we're going to look at is aspect, and this will give each cell a value between 0 and 360 degrees based on whether it's facing north, south, east or west. Now we're not actually going to generate these data sets in the GIS today, and this is quite time consuming and takes some quite powerful tools, but I just want to show them to you, familiarize them with you, and get you started thinking about how these data sets are useful within the GIS. So we're going to add this data the same way as we added all the data. We're going to zoom to our lab 3 data which we have downloaded, and let's first of all add the aspect. Now when we're dealing with data sets which have graduated values, like for example the digital elevation model, it's important when thinking about symbology and what colors we use that maybe we use a graduated scale. So the example of the digital elevation model is that the lower values have a black color, and these values then gradually increase to white as they get higher and higher and higher, and this makes sense because we have graduated values. Now with something like aspect, we don't have the same graduated value system, as in it doesn't rise between 0 and a certain amount kind of continually, and therefore when we're picking a symbology, when we're picking a color, we should be very aware of what is the best color scheme to reflect the data in hand. So if we open properties, we can see that actually we're given a huge amount of quite different and quite varied symbological options or color options, and we can see these by dropping down the color ramp. Okay, so as we look down through these, we can see that there are graduated symbols here covering all colors. Now we're getting into slightly more varied and still graduated but less so. And it's important that we pick a series of colors which are going to adequately display the variation which we're looking at. It is of course perfectly possible for one cell to be next to the other and to have a completely different value. So let's take this one here, a nice varied color scheme. Okay, I've actually picked the wrong one there, so we'll go back in. This is quite slow, as you can see. And let's actually go down and use this one here. Okay, and click apply. Now this will probably give us a very, very bright symbology, but that's okay, because what we're trying to do is just get an impression of exactly what kind of color scheme we're looking at. So let's click OK. Okay, so in this color scheme for our aspect map, we can look up here and we can see that the zoom into this part of the map here, that the blue sections are north, and then as we come down through it, we run down to the red sections being south, so we can see how we have blue on one side and then red on the other, and then we can see that the other values fall halfway in between these things. So this gives us an impression of the aspect of the landscape. Now if we want to query this aspect, we can use the query tool. So if we want to know exactly what this value here is, we can see that that value is 234 degrees. So if we're moving clockwise around with 0 being north, 180 being south, we can see that this is west facing. Okay, let's turn that off and let's add our slope map. Okay, here we have our slope map. As I said before, our slope map measures the gradient in terms of degrees, and again we need to be very conscious here of picking a sympathetic symbology for looking at this type of data. First of all, let's zoom to the maximum extent. We can do that by right clicking on the dataset and clicking on zoom to layer. And now let's pick a different dataset which is just more appropriate to slope, or a different symbology. So we do that by right clicking on 50 meter slope, properties, and again let's drop down a slope value here. Now this is painfully slow, I'm afraid, at the moment. Hopefully it'll be quicker when you guys are doing it. Let's pick this graduated system here. We have a red leading into a blue. We'll select that, and then we're going to do a little trick. We'll click the invert button, which will actually turn that round so that red will be the high slope and blue will be the low slope. So let's click OK and see what that looks like. Okay, so we can see here that most kind of middling slopes have a blue value, and as we zoom in we can see some of the higher value slopes here, and let's query some of those again. How steep is this? Well, we're being returned a value of 6 degrees. If we click over here on a blue, expect that to be a lot less. That's 0.28 degrees, so an awful lot lower. Okay, that's how we alter the symbology of slope. I've also showed you how we alter the symbology of aspect. What I'm going to do now is I'm going to remove both those data sets. We remove data sets by highlighting them and then clicking remove. This doesn't delete them, it just removes them from the digital elevation model. We can turn this digital elevation model back on, and we're going to add our aerial photographs. Okay, so we're just going to add these 4 top ones here. You can add them individually, or you can click one and then click control and highlight the rest of them. Just going to add the 2 top ones there, or the 4 top ones. And when these are there, we're going to, again, that little trick about zooming to layer. And we can see that we have added this series. Now this is actually 4 individual tiles of aerial photographs. If we were to click one off, we can see that we actually take off that one there. And we can group these together again. If you click on one and then hold down your finger on your control key, click on another, and another, and another, we can highlight multiple, and then by right clicking we can go to group. That will bring them all together in one group layer, and then we can right click on that, go to properties, and we can say call this APs, aerial photographs. Okay, and the benefit of this is means you can switch off all 4 layers at once just by clicking that. Let's zoom back out to our maximum and just see what extent we're dealing with. We can see that the aerial photographs only actually take up a very small amount of the entire area. Raster datasets can cover a much wider area, but they also tend to be much larger. This is just because they're much bigger datasets. You can see here how those 4 tiles of aerial photographs are only covering a fraction of the overall area.